So in this video, we want a quick look at how to solve two simultaneous equations where one of the equations is linear and one is non-linear. So in these sets of equations here, we have one linear equation and one, in this case, quadratic equation. And I know that the top equation is linear because it only has single powers of x. But also, if we rearrange this to y equals 3x minus 2, it looks like the equation of a straight line, and that's why we call it linear. This has an x squared in it, so we call it quadratic. Every time we have a linear and a non-linear one, we take the linear one, the easier looking one, and we rearrange it. And in this case, I'm going to rearrange that to y equals 3x minus 2. What we've done is we've made y the subject of it. It doesn't matter whether you make y the subject or x the subject, but generally there's one that's easier to do. And in this case, it's much easier to make y the subject. It's on its own. We don't have to divide through by 3, which we'd have to do if we wanted to make x the subject. So what we then do is we take our subject, y equals 3x minus 2, and we're going to substitute it into the second equation, into the non-linear one. And in this case, I know y equals x squared, but I also know y equals 3x minus 2. So what we can do is substitute 3x minus 2 instead of y, and that equals x squared. We've substituted for this value of y, we've substituted 3x minus 2. So instead of y equals x squared, we have 3x minus 2 equals x squared. Now once we've got that, this just becomes a quadratic equation. So we rearrange this. We're going 0 is equal to x squared minus 3x plus 2. And you're thinking, okay, can I think of two numbers with a product of 2 and a sum of minus 3? And actually those two numbers are minus 2 and minus 1. So this will factorize, and it becomes 0 is equal to x minus 2 upon x minus 1. I can go straight to brackets because it's a single x squared. And that's it factorized, but we want to solve that. So x minus 2 equals 0 means that x equals 2, or x minus 1 equals 0 means that x equals 1. And so we have, as we'd expect from a quadratic equation, we have two solutions. However, when you think back to simultaneous equations where we had two linear equations, whenever we solved the two equations, we always got two sets of outcomes, or a set of outcomes, sorry. And whenever we found a value of x, we had to find the corresponding value of y. We're going to do exactly the same here, except this time, instead of having one value of x and one value of y, we're going to have two values of x and corresponding values of y. So how do we get those values of y? Well, I know x is 2. Simply go back to the rearranged linear equation. Y equals 3x minus 2. Now if x is 2, y equals 3 2's minus 2. So 6 minus 2, y equals 4. And going back to here, if x is 1, well, what happens about y? Well, y is equal to 3 times 1 minus 2. So 3 minus 2 is 1. So y is equal to 1. And if you want, you can rewrite those as pairs. X equals 2 and y equals 4, or x equals 1 and y equals 1. Those are our two sets of solutions for this question. This set of simultaneous equations looks slightly harder, but we're going to go about it in exactly the same way. We have a linear equation, and this time it's a non-linear equation. It's just one with squares in it, but it's not the equation of a straight line. But we're going to take the linear one and make x or y the subject of that. Now, I could make x the subject. 3x equals 1 plus y. X is equal to 1 plus y over 3. That's okay, but it involves fractions. So what I'm actually going to do is I'm going to take that 3x minus y equals 1, and I'm going to rearrange it as 3x minus 1 equal to y. So we've made y the subject here, just slightly easier. And now what we're going to do is we're going to substitute that into this second non-linear equation. We just need to be a wee bit careful how to do that. First of all, let's write this out. So it's x squared minus xy plus 2y squared equals 5. Now, everywhere that I see y, instead of y, I'm going to substitute 3x minus 1. So let's just see how we do that. So it's x squared, there's no y there, minus x, minus xy. So instead of that y, we're going to write 3x minus 1. So I'm just putting a bracket around it. Plus 2. Now just be careful here. This is y squared. Well, y, we're writing 3x minus 1, but then we're squaring that. And that's equal to 5. So we've taken the linear and we've made x or y the subject. And then we've substituted that value into this non-linear one. Everywhere we see y, I've substituted 3x minus 1. And again, that'll work for if you substitute for x or for y. It doesn't matter. You'll get the same answers. So we now have an equation with brackets. Let's just multiply that out and see what happens. X squared minus 3x squared plus x. Just be careful with this next bit. I need to square out that bracket. Again, be careful if you need to use your FOIL method or however you multiply out brackets. But when I square that out, I get 9x squared minus 6x plus 1 equals 5. And now I still need to tidy that up a wee bit. That's x squared minus 3x squared plus x plus 18x squared minus 12x plus 2 equals 5. Which looks quite messy, but actually there's only x squareds, x's, and number terms. It's a quadratic equation. And when we simplify it down, x squared minus 3x squared plus 18x squared is 16x squared. We have a plus x and a minus 12x, which is minus 11x. And then we have a 2 and a minus 5, so that's minus 3 equals 0. And so we have a quadratic equation. I can't think of two numbers that multiply to give minus 48 and add to give minus 11. So I'm going to go straight to the quadratic formula here and say for my formula, my value of A here is 16, my value of B is minus 11, and my value of C is minus 3. So let's plug that into the formula then. So x equals minus B plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's plug our values in. X is equal to, well, minus 11 is just 11, plus or minus the square root. Again, if you're using your calculator, just be careful to put minus 11 in brackets. Minus 4 times 16 times negative 3. And that's all divided by 2 times 16, so 32. When we put that into our calculators then, to start with, we get a value of x is 0.9505, or we get, if we put the minus sign in there, we get x is equal to minus 0.2091. We get two values of x. But don't forget, our equations are all in terms of x's and y's. So we need a solution not just for x, but also for y. And actually, it's easier than we think, because what we're going to do is take this value of x and plug it into the easiest looking equation. In other words, the linear one over here. This one, we can find y by simply taking the x value, multiplying by 3, and taking away 1. And when we do that, when x is 0.9505, well, 3 times that, take away 1, gets us that y equals 1.8515. And whenever x is minus 0.2091, if we put that into here, 3 times minus 0.2091, and then take away 1, we find that y equals minus 1.6274. And I've given those answers just to 4 decimal places, but you can give that to any degree of accuracy that you're asked for, be it 2 decimal places or 3 significant figures. We could round them at that final stage, but These would be our sets of solutions. 2 sets of solutions, each with an x value and a y value. X value and y value. And so we have solved this set of simultaneous equations.